Right then, so moving on to a slight curveball. This can actually be applied to any of the scale factor equations that we've seen list. So it could be just finding, or a linear scale factor, we're just finding a side, or it's linked to area, or it's linked to volume. In this example, it's linked to volume. It's a wee bit different because we're actually dealing with the cost, and we're talking about the cost of a brick. But we've got the same setup. We've got the two bricks are similar. We have a like size in the brick, 5 and 7.5, and we're being asked to find the cost of the smaller brick. Now, as you would expect, the cost of a brick would be associated or related to its volume. The bigger the brick is, the more money you would expect it to cost because you're using more materials to make that brick, so it's going to cost more. The less materials you use, the less it's going to cost, and that's what we're going to have to use here. To be honest, it follows the exact same pattern as it would if you were given a volume here. Okay, the only difference is we're not going to deal with volume, we're going to deal with cost, but you'll see that the maths is very, very similar. Okay, so again, starting off, usual starting point is a reduction and enlargement. We've got the cost of the bigger brick, we want the cost of the smaller brick, so it's a reduction scale factor we're dealing with. Small over big, so 5 over 7.5. It's a volume. It says here the cost of the brick is related to its volume, so that's our Q to cube the reduction scale factor. We can actually simplify this. It's got a decimal there. If we didn't have a calculator, we would want rid of that decimal before we cube anything. So I can divide top and bottom by 2.5. If I do that, I'll get 2 on the top and I'll get 3 on the bottom. And just cubing that. Okay, so once we've done that, like I said, it's the exact same calculation that you would do if you were given the volume of the bigger brick. We're not, we're given the cost, but we can apply the mathematics in the same way. So the cost of the smaller brick is simply going to be the reduction scale factor times the cost of the bigger brick. So 2 over 3 cubed times, in this example, the cost of the smaller brick is 270, which I've just abbreviated 2.7. Okay, so thinking that in the calculator, 2 divided by 3 equals 0.6 recurring. Cube that, we get 0.296, blah blah blah, keeps going, and then multiply your answer by 2.7. Once we've done that, we get 0.8. Now remember, you're dealing with money here, so you need your pound sign, and you need 2 decimal places as well. So the cost of the brick would be 80p. And again, that ties in with the diagram. Smaller brick should be a smaller cost. Okay?